In this two-part question, we are firstly going to transform the graph of y is equal to cos x into this given one here. It says a function f is defined by f such that x is mapped onto 3 cos x minus 2 for 0 is less than or equal to x, which is less than or equal to 2 pi. Sketch the graph of y is equal to f of x. Now, this is going to result from transforming the graph of y is equal to cos x. Now, we know that in any function, or in any trig function, y is equal to a f of x. The a is going to change the amplitude of a graph of cos x into a units. Alright, and so what I normally do is start by comparing it to the original graph. So because my domain is from 0 to 2 pi, I'm going to make a sketch that starts from 0 and ends at 2 pi. So the original graph of y is equal to cos x looks something like this. At 0 degrees, and it goes to 0 again at pi over 2. This is pi, and this here is going to be 2 pi, and that's going to be 3 pi over 2. The maximum value is going to be 1, and the minimum value is going to be negative 1. And obviously that's your y-axis, and this is the x-axis. Now this value here is going to change the amplitude from what it originally was. The depth of each trough was 1 unit. Now if I change this into a 3, it means that the amplitude is now going to be equal to 3 units. So the maximum value is going to be 3 units, and the minimum is going to be positive 3, and the minimum value is going to be at negative 3. So just like board mass, we're going to look at the multiplication first before we are going to add or subtract. So from here, I already know that the amplitude is going to change, as I've already said. So the graph is going to look something like this. Okay, I'll always do it in parts, and then I'm going to move on from there to combine all of them into the new graph. Alright, so I've said if this is a 3, the maximum value becomes 3 there, and the minimum value is going to be negative 3. So this graph here is now going to be y is equal to 3 cos x. Right, what does this negative 2 do? So if I've got y is equal to f of x plus or minus a, what it means is that if it's a positive, we're going to transform the graph or translate it by 3 units or a units parallel to the y-axis. If it's a minus, the graph is going to get shifted by a units down. So in this case, we are looking at minus 2. So the graph is going to look something like this. What happens is each y value has to minus a negative 2 or minus 2 from each y value. So if this is my y-axis, and these were my points of interest after the latest transformation at 3, so I'm going to do 3 minus 2. As you can see, there is a minus 2, and then minus 3 minus 2, and another point of interest for y was the 0, so it becomes 0 minus 2. So the new 0 line is going to get shifted by 2 units down. So let me suppose I'm going to put it in with the dotted line like that, and say that's where the graph is now going to give me my 0 line. So 3 minus 2 is 1, so that's going to be, suppose it's 1 there, and then this stays as 0, so that's where minus 2 is going to was found. So minus 3 minus 2 is negative 5. So if I extend that line and put my negative 5 to be there, so I know this is the minimum value now. So the graph is going to look the same. The period has not changed because the x value stays the same. So that's still 1x. So it's only going to have one complete cycle between 0 and 2 pi radians. So 0 and 2 pi radians. Now let's go ahead and complete our sketch. It's going to look something like this. So it goes from there. It bottoms out at negative 5, and then it comes back up, and it should get to 2 pi there. So I just extend that to give me x. So I know that that's going to be 2 pi radians, and this here initially it was at 3 pi over 2, so now that's now 3 pi over 2, and this here was initially at pi over 2, so it stays at pi over 2 because there was no horizontal shift in this graph. So there we have it. We now have the graph of y is equal to f of x, which is 3 cos x minus 2. and we were required to draw it from 0 to 2 pi radians. Now moving on to the second part of the question, it says that a function g is defined by g such that x is mapped onto 3 cos x minus 2 for 0 is less than or equal to x, which is less than or equal to k. State the maximum value of k for which g has an inverse, hence obtain an expression for g inverse of x. Now this expression really is the same as what we've done here in the first part, but it changes because the domain has to be restricted. It's no longer going to be from 0 to 2 pi. Now we need to determine the value of k for which g has an inverse. And now you need to remember that a function has an inverse. So a function has an inverse if it is 1 to 1. Now, having a look at the graph that we have just sketched here, we know that it's going to bottom out here at pi radians. Now, a function is 1 to 1 if the horizontal line is going to cut it once throughout that given domain. Now, if you can have a look here, if I draw the function from 0 all the way up to pi here, okay, if I was to stop here, this function is going to have only 1. I'm going to sketch it here and make sure you see exactly what I'm talking to you about. It's going to look something like this here, and it starts at 1 and it wants to bottom out at this point here. Now at each and every part of this graph at the current moment, if I were to draw a horizontal line, have a look here. If I were to pick up this horizontal line here and try and trace it up against this graph here, you can see it cuts the graph more than once in the domain from 0 to 2 pi radians. Okay, but now in the new function that I've drawn here, this horizontal line is going to cut the graph only once in the given domain. But if I try and extend it beyond pi radians, the function is going to, the horizontal line is going to cut that function at 2 points. So now you can see that the maximum value for when it is going to be 1 to 1 is from 0 to pi radians. So if that is y and that is your x-axis, so it means that k is going to be equal to pi radians, and this is the only time that the graph is going to be 1 to 1. Beyond that, the graph starts doing that and the horizontal line is going to cut it twice, which is undesirable for a function to have an inverse. Now we're going to find the inverse. What we normally do is y, because you can replace that expression with just y, is equal to 3 cos x minus 2. And then you will switch the x and y values around, and so that means x is now equal to 3 cos y minus 2. We know that's what the inverse function does. The y values, the domain becomes the range, and the range becomes the domain. So now what we'll have to do is just solve for, we just have to solve for y. So cos, it will be x plus 2 is equal to 3 cos y. If I divide both sides by 3, and I have x plus 2 over 3 being equal to cos of y. Now taking the inverse of both sides, cos inverse of x plus 2 over 3 is going to be equal to y. So therefore my inverse g inverse of x is going to be equal to cos inverse of x plus 2 over 3. In the event that the examiner, and often this does get asked, they ask you for the range and domain of the inverse function. We know that the original function was starting here at 0, so the domain, the original domain was 0 is less than or equal to x, which is less than or equal to the k value which we found, and it's going to be pi, and then the range is going to be from negative to positive 1. You can have a look here in this original graph, and then the minimum value is going to be negative 5. So the range is 1 is less than or equal to y, which is less than or equal to negative 5. So because at this stage here we switch the x and the y values around, so it means the domain for the inverse function, the domain for the inverse function becomes this here. It was an x in the original function, so in the inverse that becomes the y value. So here the domain is the range, so it's going to be y is less than or equal to x, which is less than or equal to -5, and then the range of this function here was the original domain, so we're going to say 0 is less than or equal to y, which is less than or equal to pi radians.